All right, we are going to look at some more examples of comparing and contrasting the translations for radical functions. So we're going to predict the transformations first of the parent function of the square root of x, and then we're going to graph the functions to check our results. So the first graph says it's the square root of x, and then we add 2 to it outside the square root. So first I can predict this should move 2 units up because we are adding something and it is outside the radical. Now let us check our results by plugging in some points. Let's start with 0, because 0 is the smallest value that I can take a square root of and still have a real number. So I square root 0, I get 0, and then I add 2 to that. So I get the square root of 0 plus 2, which is 2. That gives me the point 0, 2. Then I can do 1, because the square root of 1 is also a nice number. It is the square root of 1 plus 2, which gives me 3. So I plot my point 1, 3. Then I have the point 4. The square root of 4 is 2. And I do the square root of 4 plus 2, which is 2 plus 2, which is 4. So go over 4 and then up 4. Now I have 3 points. I could keep going, but just for the scope of this problem, 3 points is plenty to see the shape of my square root function. So we've taken our normal parent function, which is the square root of x, which would look like this, and it's shifted up 2 units, so our prediction was correct. Let's go on and look at the second one. In the second one, I am subtracting 2 from the radical, and it is outside the radical. So I can predict that it should move 2 units down. There's my prediction. So I'm going to actually put in the same points I used, 0, 1, and 4, because I'm just square rooting x all by itself. Thus, the nice square roots of x will be the numbers that have perfect square roots, such as 0, 1, and 4. So I put in the square root of 0 minus 2, and I get 0 minus 2, or negative 2. I put in positive 1. I do the square root of 1 minus 2, which is 1 minus 2, or negative 1. And then I put in the square root of 4 minus 2. The square root of 4 is a positive 2. We're assuming the square root is positive here. We subtract 2 and I get 0. Now I plot 0, negative 2, 1, negative 1, and 4, 0, and I connect my points. Notice this is the exact same shape as my first graph. It's just been shifted 2 units down instead of 2 units up. The shape has not changed at all. It has not been stretched because we're not multiplying x by any value. All right, let's turn and look at C and D. So C has the square root of x plus 2, and the plus 2 is inside this radical. That means it moves 2 units left, and this is where sometimes people have a hard time, because they think plus 2 is right. Now, whenever we're modifying what's ever inside the radical with adding and subtracting, it's a horizontal shift. If we add, it's to the left, and if we subtract, it should be to the right. Now let's check our answer. The lowest x value I can put in and still have a real answer when I square root it is negative 2, because the square root of negative 2 plus 2 will be the square root of 0, which is 0. So this is where my graph should start. We already see that I've moved it 2 units left. Now I can also put in something like negative 1, because the square root of negative 1 plus 2 will be the square root of 1, which is 1. So plot negative 1, 1 right there. And then the last one I'll put in is a 2, because the square root of 2 plus 2 is the square root of 4, which is 2. So just notice I picked values that would give me nice integer values. You could pick values that don't give you nice integer values, but then you're probably going to need to use a calculator to figure out what it should look like. So it's easiest to pick values that when you square root them, they give you a nice whole integer. So notice it's the same exact shape as a and b, but we just shifted the original parent function of the square root of x 2 units left. All right, let's look at d. So we have d is the square root of x minus 2, and that's all inside the radical. So I can predict that that minus 2 moves the whole parent function 2 units right. Now let's check that prediction by plugging in some points. So first, let's try 2. 2 is the smallest value we should put in here because 2 minus 2 will give me 0. I cannot square root anything less than 0 and get a real answer. So I get the square root of 0, which is 0, and then I can plot 2, 0. The next value I can put in is 3 because 3 minus 2 is 1, and 1 has a nice square root. The square root of 1 is 1. Then I can put in 3, 1. Another thing I can put in is 6, because 6 minus 2 is 4, and we know what the square root of 4 is. It's 2. So now I have the point, it's a little far off my graph, 6, 2. So we connect our points and we realize that this is the exact same shape as from A, B, and C. It's just moved 2 units right. So this video really helped us compare and contrast what happens whenever we're adding something. Next video we'll look at what happens when we are stretching or reflecting something.